Assalamualaikum and good day all. My name is Muhammad Nur Faiz bin Ramlan from AS222 program. I'm a final year student of Bachelor Degree of Science, Chemistry with Management. Today, I would like to present my final year project thesis, which is Microwave Assisted Synthesis of Copper dot CaCoO3 Perovskite Oxide using Modified Sol-Gel Method. My supervisor is Muhammad Hafiz bin Yaakob. The content for this video presentation consists of 5 chapters. Chapter 1 is Introduction, and we will focus on research background, problem statement, objective and significance of study. Perovskite oxide have been derived from a general formula AbO3. According to Boucher and Aurat 2020, perovskite oxide with a general formula AbO3 have attracted a great deal of attention since they can exhibit a variety of interesting physical properties from both academic and technological aspects. So, photocatalytic degradation of methylene blue were obtained by using copper dot CaCoO3 perovskite oxide as a catalyst. This perovskite oxide was prepared by microwave assisted using modified Sol-Gel method, and metal nitrate have been used as a precursor. For the problem statement, current researchers found that the formation of this perovskite oxide is very dependent on its preparation method. It is difficult to prepare high homogeneity in terms of nanoparticle size by using Sol-Gel method. Thus, it should be assisted by microwave irradiation. As mentioned by CaCoO3 et al. 2018, microwave assisted method result in high yield of uniform perovskite oxide nanostructure and short the time of reaction. Moreover, researchers found the key problem in preparation of perovskite oxide were controlling particle size and composition, as well as controlling the interface and distribution of nanostructure perovskite oxide compound. Thus, wet chemical method, which is Sol-Gel method, was used instead of conventional method in this study. According to Wu and Zhu 2016, Sol-Gel method offer greatly decreased diffusion distance and product can be produced at much lower temperature. The objective of this research is to synthesize the copper dot CaCoO3 perovskite oxide using microwave assisted modified Sol-Gel method, to study the photocatalytic degradation of methylene blue, and to determine the chemical properties of copper dot CaCoO3 perovskite oxide using FTIR. Moving on to chapter 2, which is a literature review. Perovskite oxide nanocrystal is formed with a general formula AbO3, where A is alkaline or rare earth metal, while B is transition metal. Based on Jung and Hong 2013, traditional AbO3 perovskite oxide exhibit higher catalytic activity. So, in order to achieve the highest photocatalytic activity, the perovskite oxide was doped with transition metal, which is copper. The study conducted by Shom et al. As cited in Sharma et al. 2020, copper doping at B site in perovskite oxide show enhancement in catalytic activity. As mentioned before, wet chemical method with Sol-Gel method was used in this research because of its provide lower operating temperature, reducing the potential to lose alkali metal oxide, as noted by Chowdhury et al. 2019 in their study, that the compound may be a strong catalyst. In addition, a study by Chadley et al. 2016 found that the Sol-Gel method is desirable as the result of the reaction can be influenced by careful control of many reaction variables, and it was considered as a synthetic method due to the potential to produce a uniform size within a nanometer range. Chelating agent play an important role in binding the whole metal cation to form a metal complex, and also can reduce the temperature of the reaction. So, citric acid was used in this study as a chelating agent because a study by Toniolo et al. 2012 showed that citric acid was used as chelating agent in order to obtain an easy control over the final stoichiometry. Low reaction temperature without intermediate grinding and enhance uniformity of the resultant product. In other study conducted by Ho et al. 2016, which is they use citric acid as a chelating agent, and they found a small particle size of perovskite oxide with an average diameter of 500 nanometer. Besides, polymerization agent, which is diethylene glycol, should also be introduced in Sol-Gel method in addition to the chelating agent. Next, we go to subtopic 2.3, which is microwave assisted method. As we can see here, this is the comparison between microwave assisted method and conventional method as mentioned in the study of CaCoO3 et al. 2018. Microwave assisted method has many advantages, such as the production of small and uniform particle size, controlled morphologies, high crystallinity and purity owing to short reaction time, high yield, process simplicity, energy conservation, and at the same time offer a cost effective. In subtopic 2.4, we will focus on characterization of perovskite oxide using FTIR analysis. A study by Serrano et al. 2016 with a title of a precursor for a highly efficient catalyst for hydrogen production from glycerol found that the platinum and copper are shown to be more effective dopant compared to aurum and silver. Then, the metal oxygen bond of COO6 are located in range of 586 to 592 per centimeter, and nitrate ion group are detected at 1300 18 per centimeter and 1471 per centimeter. Next, Erdeni et al. 2017, with the title of study is lanthanum-based perovskite oxide as a catalyst, observed the vibration band around 600 per centimeter that assigned to CaCoO6 octahedron. A study by Zhang and Hong 2013 observed that the band of absorption shift to the higher wavelength because of the rise in temperature of calcination. Thus, the photocatalytic activity also increased with increasing in calcination temperature. Then, a study conducted by Jayapandi Lakshmi et al. 2018 record that the absorption of methylene blue decreased following the addition of perovskite oxide. They observed the degradation of LaCoO3 and silver dot LaCoO3 with 75% and 99% respectively. The chapter 3, which is methodology. As we can see here, this is a flowchart of how the experiment of this study will perform. Firstly, the metal nitrate will calculate the stoichiometry mass which can be used as received that not subjected to any processing. Metal nitrate will dissolve together in 100 milliliter of deionized water and it will form metal nitrate solution. Then, the calculated amount of citric acid was added with mole ratio between metal nitrate salt and citric acid is around 1 to 1.5. pH value was adjusted to pH 8 by added ammonium hydroxide. The mixture was continuously stirred at 70 degrees Celsius for 10 minutes. After that, diethylene glycol was added into the mixture with molar ratio between diethylene glycol and citric acid is about 1 to 1. The mixed solution will stirring continuously until a gel is formed, and this precursor gel will heated to dry at 115 degrees Celsius for 24 hours using oven, and a red zero gel will produce. The precursor gel are exposed for 5 minutes to microwave irradiation. Lastly, the irradiated dried gel has been ground into powder and calcinate for 8 hours at 1100 degrees Celsius. After that, the perovskite powder are ready to be characterized and test for the photocatalytic degradation of methylene blue. Chapter 4, which is result and discussion. From FTIR analysis, the perovskite oxide powder was analyzed by using FTIR spectroscopy in order to identify the functional group, presence of nitrate group, and interaction of metal with oxygen. The summarization of corresponding bond of FTIR with number are shown in this table. Based on the FTIR spectrum of perovskite oxide shows the absorption of metal oxide, which is interaction between metal cobalt and with oxygen at peak 688 per centimeter. Then the peak at 620 per centimeter correspond to CaCoO3 perovskite oxide due to incomplete reaction for copper atom to combine with A side of perovskite oxide, which is calcium atom. By doping the CaCoO3 perovskite oxide with copper, which is transition metal, will result in strong absorption peak and shift to the higher wave number. Next, peak at 1410 per centimeter indicate the presence of nitrate ion impurities due to it have not been completely decomposed and are still trapped in the perovskite oxide powder. The data for methylene blue degradation are summarized and shown in the table. The perovskite oxide as a photocatalyst were then tested for the degradation methylene blue at a concentration of about 100 ppm. From the graph, it can be observed the percentage of degradation of methylene blue is 12.7% for 20 minutes of degradation time and 50.4% for 120 minutes of degradation time. Methylene blue as organic pollutant has been successfully degraded by this perovskite oxide due to the presence of CaCoO6 octahedron and the containing of cobalt ion which in perovskite, which is play the important role in the photocatalytic degradation of methylene blue. We move to the last chapter, which is conclusion and recommendation. As a conclusion, copper dot CaCoO3 perovskite oxide was successfully prepared by using modified soil method with microwave assisted. The metal nitrate have been used in this study as a precursor material, and the perovskite oxide is formed after exposed to the microwave irradiation for 5 minutes, followed by calcine at 1100 degrees Celsius for 8 hours. Then, methylene blue as organic pollutant has been successfully degraded by copper dot CaCoO3 perovskite oxide. As the recommendation, the future researchers who want to focus on prepared perovskite oxide are recommended to conduct the study using various concentration of copper that used as a dopant. It's also a good idea to expose the zero gel to microwave irradiation for varying period of time or different heating power.